All right, so this numerical is from Resnick Halliday, and the topic is power. See, power is nothing but the rate at which work is being done on a body. The other way to express this is the rate at which energy is being supplied to the body. Essentially, power is work divided by time, and this is what is the rate. The rate is being calculated with respect to time. So if you deliver 2 joules to a body in 2 seconds, your rate is 2 divided by 2, which is 1 joule per second. But there are many other ways you can express power with the help of dot product, and this is the focus of the question. You will come across many situations while doing numericals in AP Physics and JEE Mains in India, where this particular usage of dot product to calculate power or the energy being delivered to a body will be used. So let's start this numerical and solve it using the concept of dot product. Thank you. This question is from Resnick Halliday, and as you can see, there are 3 situations which are depicted, and it says that the velocity and the corresponding force. Situation number 1, this is the velocity, this is the force, this is the velocity. Situation number 2, and the corresponding force is this. And the way I look at this question is that the question has a lot of emphasis on vectors. So there is a velocity vector and a force vector which is given to me, and there are 3 situations in which force and velocity are interacting with each other. We have to rank the situations according to the rate at which energy is being transferred. Greatest transfer to the ranked first, greatest transferred from the particle ranked last. So you can see there are 2 words being used: greatest transferred to the body and the greatest transferred from the body. So in one case the body is delivering power back to you, and in the other case you're delivering power to the body, right? Which means if you do work on the body, the energy of the body goes up. This could go up in the form of its increased kinetic energy. Okay, so and the body may lose energy. For example, in the case of friction, the body tends to lose energy because the frictional force opposes the velocity. So let's discuss this one by one and see what's happening. For your information, as we discussed in the start of this video, the work done is the concept, and when we do the rate of work done, this becomes actually power. But the other way to express power is this. Okay, so work is force into cos of the angle between them, right? This is F dot S divided by time, and you can convert this whole thing into F dot V, okay, where F V. So if I write it as modulus of F into modulus of V into cos of angle between the force vector and the velocity vector. In the given question, the approach is we will take the dot products of vectors because the vectors are given in I, J, K notation. I think there is no K, there's only I and J, so it's a 2-dimensional problem. Let's consider the first one, which is F is given to be 6I minus 20J and velocity is equal to minus 4I. So the power is equal to F dot V is equal to 6I minus 20J dot minus 4I, right? So this will become 6 into 4 minus 24. I dot I will become 1. J dot I, okay, J dot I is modulus of J, which is 1, modulus of I, which is 1, cos of 90 is equal to 0. So essentially our answer is minus 24 power, right? So this is in watts. Let's consider case number 2, where the force is equal to minus 2I. I think it's okay, so there is a K here, sorry, minus 2J plus 7K, and the velocity is given to be 2I minus 3J. So the power is F dot V, so minus 2J plus 7K and 2I minus 3J. So I think the only ones which are relevant here are the ones which is the force J, this is J, and this is another J available to us. Okay, so only these two matter. So 6 watts. All the other dot products like K dot I, K dot J, all of this becomes 0 because the angle between them is 0. So you got a plus 6 watt, right? So you are supplying power in this case. Let's consider the case number 3. So the idea, there are two ideas which are running in this question. One idea is, of course, the idea of dot product is, you can calculate power using dot product. The second idea which is running in this question is whether you're delivering power to the body or you're taking away power from it, right? As I gave you the example of friction, you're taking energy from the body at a certain rate, which means you are extracting energy out of it, right? So the body is transferring energy to the road, for example. The road will get hot, right? Because the energy is getting dissipated. Typical of friction. So you can watch my playlist on friction, some numericals from Resnick, Elliott, and numerous other conceptual videos. Let's talk about situation number 3. So this is F dot V again, and this is F is 2I plus 6J and minus 3I plus J is equal to, so you have, in this case, what you have is I here, right? So this is minus 6 watt. So as you can see, we have 3 answers. The first answer is minus 24 watt. So a lot of energy being dissipated, okay? And you can see the greatest transfer from the particle, right? So this will be ranked last. This particle is losing energy like hell, it's losing 24 joules every second it moves. Maybe friction or some drag or something is making it lose energy. The second thing which is important is this particular body, which is 2, is gaining 6 joules every second. Somebody is pushing it, accelerating it, and it's gaining energy, right? So we will say this will be first, right? Because it says the greatest transfer to the particle. So this is your first one, and this is again dissipation. The body is losing energy. So this is second. Okay. So first, second, and third. So keep in mind when you do power questions, they are seemingly very innocent because you're doing only dot product, but please also be very careful whether the power is being delivered to the body or the power is being taken away from the body. And the sign changes. You can see when the power is being taken away or from the body, the power being calculated is negative power, which means the body is probably losing its energy at a certain rate. So I hope this helps you understand the power of dot product, and also the fact that sign convention is also very important in the case of such questions. You can come across many larger numericals where this concept may be of tremendous use to you while calculating the questions. So thank you for your time today. Don't forget to subscribe to my channel and look forward to see you soon. Thank you very much.